Hello everybody, this is a video about compound probability. I am your host, Mr. Shirley, coming at you with the math. I hope you've printed out the note for this subject that's in Classroom so you can fill in some of that as we go. Okay, before you get started, I'd like you to try out, so pause the video, try out the warm-up and see how you do. Okay, just to review from last time. Okay, we'll assume you did that. So your tree diagram, which again can be drawn in any direction, but if you have a skinny space like this, it's probably best to go downward or upward. And what you should have had, you've got three different choices, A, B, and C. They've got the choices just conveniently laid out for you right there, and 5 possible corrals that you could end up in. So how many different wave and corral assignments are there? We talked about this last time, that you can find that out just by multiplying. So you've got 3 choices in the first for the first possible choice, 5 for the second possible choice, so you can do 3 times 5, which means there are 15 different possibilities for where you could end up in this marathon starting time thing. Okay, so that again will be your denominator when you're finding a specific probability. Okay, so the probability of wave B corral 5, there's only one way that happens, so wave B corral 5, so that means your probability is 1 out of 15. Okay, hopefully that was fresh in your memory from before. Okay, now compound events, as opposed to simple events that we did before, are basically the probability of 2 or more events happening. So 2 or more simple events. Okay, so that's what compound typically means. So with independent events, and I'm just going to get a pen here so I can underline some of this. So the outcome of one event does not affect the outcome of the other event. So again, because the events are independent, their outcomes do not affect each other. Okay, and the probability of these can be found just by multiplying the probability of the first event by the probability of the second event. Okay, so it's basically like you're doing simple probability twice and then multiplying them together. Okay, so it's not too tricky. But you do need to just be a little careful as you're going through it. Okay, so right here, so what is the probability of rolling a standard die twice and getting an even number and then 5? Okay, so the probability of getting an even number would be 3 out of 6, right? Because there's 3 things that are even on that dice. Hopefully that's pretty easy. And then 5, so that's 1 out of 6. And then you multiply it together. So remember, top times top, bottom times bottom. You end up with 3 out of 36, which reduces to 1 over 12. Okay, now you can simplify things for yourself just a little bit by reducing numbers to lowest terms in advance before you do the multiplication. So for example, 3 over 6 here, you could reduce that to 1/2 before you even start. And then you would multiply that times 1/6, then you would end up going straight to 1/12. Okay, so you can do that either way. Sometimes as we're going through this lesson, I'll do one way or the other way. I'll try and make note of it when I pick one or the other, but I just want you to know that you could do that. Okay, I'll leave that a little bit up to you, what you feel comfortable with. Okay, so what is the probability of tossing a coin 3 times and getting tails each time? Okay, so again, these are independent because the first flip has no bearing on what you're likely to get on the second flip. Okay, again, assuming your coin is not something rigged that always flips the same way. So the first flip, you have a 1 in 2 chance of getting tails. The second flip, you still have a 1 in 2 chance of getting tails. And the third flip, still a 1 in 2 chance of getting tails. So you multiply all that together. So 1 times 1 times 1 is 1. And 2 times 2 times 2 is 8, not 6. Don't do that. So the probability is 1 over 8. And that's the probability of tossing a coin 3 times and getting tails each time. Now you could find out some of these answers as well if you were to create a tree like we did in the previous lesson, and at the top there, you could create a tree for these decisions and find exactly the same thing, okay? But in many cases, it's simpler to just do it like this. Okay, so this is us doing it without the tree. All right, on we go. I think. There we go. So we'll just do another example or two on this page, and then you will be off to the races. Now, so probability of a quadrilateral, again using the spinner thingy here, and then a standard die is rolled. So probability of a quadrilateral, and by my my count there, that was about 3/4 of them were quadrilaterals. In this case, there were 6, so 6 out of 8 are quadrilaterals, and that reduces to 3/4, okay? And then the probability of rolling a 6 would be 1/6. Again, if you're familiar with certain ways of reducing fractions before you multiply, feel free to do those. I won't go into them right now in an effort not to confuse anyone that's not familiar with it. I don't want to introduce another new thing. But if you're familiar with it, go ahead and do that. Simplify that for yourself. But doing it just the way it is there, you would end up with 3/24, which reduces to 1/8. Okay, so always reduce to lowest terms if you can with these ones. All right, down we go. And just a reminder too, if I'm going too fast, please just pause the video or go back and go over it again, especially check out that awesome picture on the first slide, and just go over it again if you need to. Okay, go back to my pen here. There is a shortcut to get the pen to show up, but it just is not working so well on my smartboard currently. All right, so in dependent events, the outcome of one event does affect the outcome. Okay, so it does affect that outcome, again, because that's what dependent means. The events are dependent on each other. Now, you still use multiplying to find your answer, but the probability, so let me read through this here. So probability of 2 dependent events is found by multiplying the probability of the first event by the probability of the second event after the first event has already occurred. Okay, now that is sometimes easier to actually see in an example than it is to think about theoretically. Okay, so it just means you have to adjust your numbers slightly for that second probability based on what happened in the first one. Okay, so for the example here, we'll go through this one and then I'll let you try these out on your own. I think this is as far as I went. Yes, it is. So there are 3 green markers, 6 yellow markers, 4 red markers, 12 blue markers, and a pencil box. So a marker is drawn, not replaced, and then another marker is drawn. Okay, so the marker's not put back in the bag. Okay, oh, sorry, in the box. So find each probability. So the probability of red, first of all, is 4 out of 25. Okay, so because there's 4 red markers, and if I did my math right, 25 possible markers you could pull out of the box. Let's do a quick check. I think I did that right. So that's your probability of pulling red. Now, the probability of blue, though, is altered slightly because now there's 1 less marker in the box. Okay, so there are 12 blue markers, but now your denominator is only 24 because you already took out a red marker or some marker. So you took 1 out. Okay, so that means your denominator is now 24. Okay, and again, you could reduce that 12/24 to 1/2 and save yourself a little bit of math later. I won't do that, but it makes it so you have to do a little bit less reducing later. Okay, so multiplying that out, you end up with 48/600, which I'm sure you all know right off the top of your head reduces to 2/25. But again, if you reduce that number here, you have less reducing later, so it's often a better way to do it. Now, things get even slightly more complicated with example C, where the probability is both blue. Okay, so the probability of picking blue twice. Okay, so the first one is the more straightforward one. So you have a 12 out of 25 chance of picking that blue marker the first time. Okay, but the second time you reach in, because we're not putting the marker back in the box, now there are only 11 blue markers in there because you already took 1 out. And there's also only 24 total markers because you've removed 1 from the first time. Okay, so you're having to change both the numerator and the denominator. Okay, again, you can do a little bit of reducing here, but you'd end up with 132/600 by multiplying those together, which reduces to 11/50. Okay, so the probabilities can get slightly tricky because you're having to take into account each one that happened before. So you can see how if you're doing more numbers, so a third number or a fourth number. So for example, if it was probability of red, then blue, then green, then yellow, and you're having to take into account what's happened before, you can see how this can get trickier and trickier. Okay, but for just two simple events, one after the other, the math in and of itself is not too complicated. So just be careful as you're doing it, double check your work, make sure it makes sense, and please let me know as you're going through it if you have any questions. Have a great day, everybody.